Okay, in this video, we're going to explain how to graph a sink, face portrait. Face portrait. Okay, if we have a sink, that means that the system looks like this. Dx dt equal ax plus by. dy dt equals cx plus dy. The matrix of the system is A, B, C, D. And in this case, the solution of this equation is two numbers that are negative because we have a sink. Then what we do is we compute the eigenvectors. Let's suppose that here we have an eigenvector b1 and b2, and we compute this eigenvector, which is w1, w2. Then what we do is we put the 0, 0. We draw the vector b1, b2, and then we draw the line. And this line is supposed to be viewed as two semilines. Here we label this as lambda 1. And since lambda 1 is negative, we do the arrows in that semi-line going in. Here we do the other semi-line. We pick a point here. This is the point W1, W2, which is a particular eigenvector that goes with this eigenvalue. Again, since lambda 2 is negative, the arrows goes down. And then we have like 4 quadrants. And in each quadrant, we're going to draw an orbit. All the other orbits are similar. But then what we do is we represent lambda 1 and lambda 2 in the real line. Here is 0. In this case, I have lambda 2, lambda 1. I notice that lambda 2 is closer to 0 than lambda 1. That means that along this line, along the line that goes with the direction of the eigenvector for lambda 2, because lambda 2 is closer to the origin, I will do, near the origin, I will do something that looks tangent to this line. And far away from the origin, I will do something that looks parallel to the other line. Then this is the orbit. It looks like this. Here, we do the same. Near the origin, we are supposed to be close to lambda 2 because lambda 2 is closer to 0. Then we do like this. And far away is parallel to this line, almost parallel. Remember that these two lines, these two orbits are not touching, right? If it is that this is too thick, then we do the other orbit like this, and the other orbit like this. The reason it's called a sink is because in each orbit you go toward a single orbit, the equilibrium point. Remember, this is a sink. Okay, and that's it.